What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about application attacks such as integer overflows, request forgeries, API attacks, resource exhaustion, memory leaks, SSL stripping, driver manipulation, and pass the hash. Let's talk about an integer overflow. So an integer overflow, this is also known as a wraparound, and this occurs when an arithmetic operation outputs a numeric value that falls outside allocated memory space or overflows the range of the given value of the integer. Mostly in all programming languages, integer values are allocated limited bits of storage. So for example, a 16-bit integer value could possibly store an unsigned integer ranging from 0 to 65,535, or a signed integer ranging from negative 32,768 to 32,767. So during an arithmetic operation, if the results require more than the allocated space, like 65,535 plus 1, the compiler may completely ignore the error that is caused or simply abort the program. A way you can visualize an integer overflow is to think of a car that has a 6-digit analog odometer that reads 999,999 miles. Now visualize somebody driving that car 1 extra mile to reach mile 1 million on the odometer. Being that the analog odometer can only display 6 digits, exactly what's going to happen when mile 1 million is reached? Well, what's going to happen is that the odometer is going to be reset all the way back to 000,000, as if this was a brand new car fresh off the assembly line. The only problem is this is not a brand new car. This is a car that has 1 million miles logged on it, but it just can't physically display 1 million miles on the analog odometer. As this example relates to computer programming, in theory, after the car reaches mile 1 million, the car would then open itself up to all types of problems with its engine and overall performance, which would be further proof that just because the analog odometer says 000,000, it still is not a brand new car fresh off the factory floor. So that's the basic concept. Now, as this directly relates to programming, most compilers will ignore the overflow and store unexpected outputs or errors. This would result in various attacks such as buffer overflows, which is the most common attack and leads to executing malicious programs or privilege escalation. Let's talk about cross-site request forgeries. So a cross-site request forgery attack. This is a cyber attack that tricks a user into accidentally using their credentials to invoke a state-changing activity, such as transferring funds from their account, changing their email address and password, or some other undesired action. While the potential impact against a regular user is substantial, a successful cross-site request forgery attack against an administrative account can compromise an entire server, potentially resulting in a complete takeover of a web application, API, or other service. Next, we have a server-side request forgery. So a server-side request forgery, this is an attack where a bad actor can abuse the functionality on the server to read or update internal resources. The attacker can supply or modify a URL, which the code running on the server will read or submit data to, and by carefully selecting the URLs, the attacker may be able to read server configurations such as AWS metadata, connect to internal services like HTTP-enabled databases, or perform post requests towards internal services which are not intended to be exposed. Next, we have an application programming interface attack or an API attack. So an API, this is a connection between computers or between computer programs. It's a type of software interface offering a service to other pieces of software. In contrast to a user interface, which connects a computer to a person, an API connects computers or pieces of software to each other. It is not intended to be used directly by a person or the end user other than a computer programmer who is incorporating it into software. An API attack is an abusive or manipulative usage or attempted usage of an API, which is commonly used to breach data or manipulate a commerce solution, such as broken access control, DDoS attacks, SQL injections, man-in-the-middle attacks, excessive data exposure, improper assets management, unencrypted communications, and broken user authentication. And here are some of the recommended best practices for securing APIs. So first one, you want to secure API services to only provide HTTPS endpoints with a strong version of TLS or transport layer security. You want to validate parameters in the application and sanitize incoming data from API clients. You want to explicitly scan for common attack signatures because injection attacks, they often betray themselves by following common patterns. You want to use strong authentication and authorization standards. You want to use reputable and standard libraries to create the APIs. You want to segment API implementation and API security into distinct tiers. Doing so frees up the API developer to focus completely on the application domain. You want to identify what data should be publicly available and what is sensitive information. If possible, you want to have a security expert do the API code verification. You want to make internal API documentation mandatory, and you want to avoid discussing company API development or any other application development on public forums. Next, we have resource exhaustion. So resource exhaustion attacks are computer security exploits that crash, hang, or otherwise interfere with the targeted program or system. They are a form of denial of service or DOS attack, but are different from DDoS attacks or distributed denial of service attacks, which involve a network host such as a web server with requests from many locations. Resource exhaustion attacks generally exploit a software bug or design deficiency. In software with manual memory management that's most commonly written in C or C++, memory leaks are a very common bug that is exploited for resource exhaustion. And speaking of memory leaks, so a memory leak, this is the type of resource leak that occurs when a computer program incorrectly manages memory allocations in a way that memory which is no longer needed is not released. A memory leak may also happen when an object is stored in memory but cannot be accessed by running the code. A memory leak has symptoms similar to a number of other problems and generally can only be diagnosed by a programmer with access to the program's source code. A memory leak reduces the performance of the computer by reducing the amount of available memory. Eventually, in the worst case, too much of the available memory may become allocated and all or part of the system or device stops working correctly. The application may fail or the system slows down due to thrashing. Memory leaks may not be serious or even detectable by normal means. In modern operating systems, normal memory used by an application is released when the application terminates. This means that a memory leak in a program that only runs for a short time may not be noticed and is rarely serious. Next, we have secure sockets layer stripping, so SSL stripping. This is another form of a man-in-the-middle attack. When it comes to HTTPS traffic between a client and a server, a hacker can't break into the legitimate HTTPS traffic even if they manage to intercept and relay the communications. When it comes to SSL stripping, the attacker downgrades the communications between the client and server into an unencrypted format to be able to stage a man-in-the-middle attack. When a victim wants to connect to a server, the attacker intercepts the request and creates an independent, legitimate connection to the server through HTTPS protocol. When the attacker receives the server's response, they relay it to the victim in an unencrypted format, posing as the server. The victim, thinking that they are communicating with the legitimate party, will continue to send information to the attacker, who will then relay it to the server in HTTPS. A way to check to see if you've been victimized by SSL stripping is to check the browser address bar to see if you are connected through the unencrypted HTTP protocol. An effective way to prevent SSL stripping is to install the HTTPS Everywhere browser extension, which will enforce HTTPS communication wherever possible and prevent an uninvited party from downgrading your communication to HTTP. Next is driver manipulation. So this is when an attacker reaches down into device drivers to manipulate them in ways that undermine security. And two types of driver manipulations that you need to be concerned with for the Security Plus 601 examination are shimming, and this is additional code that could be run instead of the original driver. So when an application attempts to call an older driver, the operating system intercepts the call and redirects it to run the shim code instead, and then you have refactoring. This is the process of rewriting the internal processing of the code without changing its external behavior. It is usually done to correct problems that are related to software design. And then we have what is called pass the hash. So pass the hash, this is a hacking technique that allows an attacker to authenticate to a remote server or service by using the underlying hash of a user's password instead of requiring the associated plain text password as is normally the case. It replaces the need for stealing the plain text password with merely stealing the hash and using that to authenticate with. An attacker obtains valid username and password hash values. They are then able to use that information to authenticate to a remote server or service using a LAN manager or a new technology LAN manager authentication without the need to brute force the hashes to obtain the clear text password. The attack exploits an implementation weakness in the authentication protocol where password hashes remain static from session to session until the password is changed. All right, so that was my quick little class on application attacks. So let's go ahead and do some of this wonderful check on learning. So the first question is, what occurs when arithmetic operations attempt to create a numeric value that is too big for the available memory space? Is this called shimming, an integer overflow, a SQL injection, or a DDoS attack? So what occurs when arithmetic operations attempt to create a numeric value that is too big for the available memory space? And the correct answer is, this would be an integer overflow. Next question. Which of the following is generally a best practice to protect APIs? Would it be securing API services to provide only HTTPS endpoints with a strong version of TLS? Would it be validating parameters in the application and sanitizing incoming data from API clients? Would it be explicitly scanning for common attack signatures? Or would it be all of the above? So which of these is considered a best practice to protect APIs? And the correct answer is, this will be all of the above are the correct answer. Next question. Which of the following is a driver manipulation attack where an attacker adds a small library that intercepts API calls? Would this be a kernel module attack, a request forgery, refactoring, or shimming? So which of these is a driver manipulation attack where an attacker adds a small library that intercepts API calls? And the correct answer is, this would be shimming. All right, so in summary, we have talked about application attacks such as integer overflows, request forgeries, API attacks, resource exhaustion, memory leaks, SSL stripping, driver manipulation, and pass the hash. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.